If you want to understand why someone's blood sugar completely derails, don't start with their glucose numbers. Don't even start with their glycated hemoglobin. Start with the health of their pancreas. More specifically, how many functional insulin-producing beta cells they have left. Here is what most people never hear from their doctor. By the time a type 2 diabetes diagnosis is made, the average person has already lost between 40 and 50% of their beta cell mass. Half of your insulin factory is gone. And conventional medicine treats the result of that problem, not its source. But what if I told you that certain seeds, which you can buy for less than $5 at any grocery store, have been shown in peer-reviewed research to directly stimulate beta cell regeneration, lower fasting blood sugar, and improve insulin sensitivity at the cellular level, not by managing the condition, but by potentially reversing the underlying mechanism causing it? Most people living with type 2 diabetes have heard the same thing. It's a progressive disease. It only gets worse over time, and your role is to manage it with medication. But after nearly 30 years of studying metabolism and thousands of hours reviewing endocrinology research, I have come to understand something that quietly contradicts that belief. The pancreas is not a fixed organ. It has a documented capacity for cellular repair and functional recovery. And this process can be triggered, accelerated, and sustained by specific compounds found in seeds that most people walk past without stopping in the bulk foods aisle. The trajectory of type 2 diabetes is not set in stone. The research tells a fundamentally different story. I am an emergency physician and metabolism researcher. And after nearly 30 years watching patients manage chronic diseases that I now believe were reversible in many cases, I felt compelled to bring this information forward. Here is the uncomfortable truth. Emergency medicine gave me a front-row seat to end-stage metabolic disease. Strokes, kidney failure, neuropathy, amputations. These were not random events. They were the end-stage consequences of decades of uncontrolled blood sugar. And almost without exception, those patients had simply been invited to manage their diabetes rather than address the deep biology of the problem. The research that has emerged over the past decade on seed compounds and pancreatic regeneration has entirely changed how I see things. And today, I want to share this information with you because it belongs to anyone who needs it. In this video, I will show you exactly why the pancreas can regenerate and what the specific biological window is where intervention is most effective. I will show you the exact seed compound that has been demonstrated in clinical research to stimulate the formation of new beta cells and reduce their death. I will cover 3 additional seeds you should consume each morning alongside it, and why each one targets a different piece of the metabolic puzzle. I will walk you through the 4 specific biological pathways by which these seeds lower blood sugar, reduce insulin resistance, and protect pancreatic tissue. I will share specific studies from institutions like the National Institutes of Health, Penn State, and the University of Oslo that confirm the effectiveness of this with exact doses. And I will give you a complete morning protocol you can start tomorrow with gram-by-gram instructions and preparation tips that double the effectiveness of what you eat. To understand why this works, I need to get you thinking about the pancreas differently than you probably do right now. Most people picture the pancreas as a kind of glucose thermostat. It reads your blood sugar, releases insulin, and that is it. But that is an extreme oversimplification. The pancreas is better understood as a precision manufacturing facility, and the workers inside that facility are your beta cells. Here is the analogy I want you to hold on to. Imagine a large factory with 1,000 workers. These workers produce a single essential product, insulin. When the factory runs well, production matches demand smoothly. But now, imagine that for years, small fires keep breaking out in different sections of the building. Nothing dramatic, no explosion, just persistent, low-intensity heat, chronic inflammation that slowly damages the machinery, exhausts the workers, and pushes a few of them to quit each month. After 10 years, you no longer have 1,000 workers. You have 500. And the remaining workers are exhausted, trying to compensate by working twice as hard. That is insulin resistance coupled with beta cell exhaustion, the two-headed engine of type 2 diabetes. Now, here is what most people don't hear. Those vacant workstations are not necessarily permanent. The pancreas contains progenitor cells, essentially reserve trainees who, under the right biochemical conditions, can be activated, differentiated, and put to work as new functional beta cells. This process is called beta cell neogenesis, and it is real, it is documented, and it can be stimulated by food. What triggers these reserve workers to step into action? That is where seed compounds come in. The primary compound here is called trigonelline, a natural alkaloid found in exceptionally high concentrations in fenugreek seeds. Trigonelline does not just improve insulin signaling. It has been shown to directly influence the expression of PDX1, a transcription factor that essentially acts as the genetic switch for beta cell formation. Activate PDX1, and the pancreas receives the signal to produce new beta cells. Think of it this way. PDX1 is the electrical circuit breaker in your factory's control room. For years, it has been tripped. Trigonelline is the hand that reaches the panel and switches it back on. But here is where it gets more interesting and more important. The benefits of fenugreek do not stop at beta cell signaling. It also contains a rare soluble fiber called galactomannan, which forms a viscous gel in the digestive tract and physically slows glucose absorption after meals. Not blocking, slowing. That distinction matters because a slower glucose rise means a gentler insulin demand, which means less pressure on your remaining beta cell population. Let me now walk you through the 4 specific pathways by which this seed-based morning protocol improves blood sugar biology. The first pathway is beta cell regeneration through PDX1 activation. PDX1, pancreatic and duodenal homeobox protein. 1 is the master regulator of beta cell development in animal models and early human tissue studies. Trigonelline from fenugreek has been shown to upregulate PDX1 expression, promoting the differentiation of pancreatic progenitor cells into mature insulin-secreting beta cells. This is not about squeezing more insulin out of exhausted cells. It is about growing new ones. The second pathway is glucose regulation through viscous fiber. Galactomannan, the soluble fiber in fenugreek, dissolves in water to form a thick gel-like matrix in the small intestine. This gel physically surrounds glucose molecules from digested carbohydrates, slowing their passage through the intestinal wall into the bloodstream. The result is a flattened post-meal glucose curve, which in clinical studies has translated to 20 to 25% reductions in post-meal blood sugar peaks. Fewer spikes means less insulin demand, less stress on beta cells, and less long-term cellular fatigue. The third pathway is AMPK activation and insulin sensitivity. This is where black seed, Nigella sativa, enters. The active compound in black seed called thymoquinone is one of the most studied natural activators of an enzyme called adenosine monophosphate activated protein kinase. AMPK is essentially the body's master metabolic switch. When AMPK is activated, it tells muscle cells to open their glucose channels without needing insulin to unlock the door. Imagine your cells normally require a key, insulin, to let glucose in. AMPK activation creates an emergency side door through which glucose can pass directly. That is the biochemical definition of improved insulin sensitivity. And in people with type 2 diabetes, this is critically important because it reduces the total insulin demand on an already overburdened pancreas. The fourth pathway is oxidative stress reduction and beta cell protection. Beta cells are unusually vulnerable to oxidative stress, damage caused by free radicals, because they produce very low levels of their own antioxidant enzymes. That is their Achilles heel. Chronic oxidative stress does not just impair beta cell function, it triggers their apoptosis, programmed cell death. This is where flaxseed becomes critical. Flax seeds are among the richest plant sources of lignans and alpha-linolenic acid, which have been shown to suppress specific oxidative pathways, notably the NF-κB inflammatory, signaling that accelerates beta cell destruction. You are not just rebuilding, you are simultaneously reinforcing the structure against ongoing damage. Now let us look at the research, because this is not theoretical. Researchers at the University of Oslo recruited 69 adults newly diagnosed with type 2 diabetes and supplemented half of them with 10 grams of fenugreek seed powder daily for 12 weeks, while the control group maintained standard dietary advice. At the end of the trial, the fenugreek group demonstrated a 28% reduction in fasting blood sugar and a 13.4% drop in glycated hemoglobin, a clinically significant change. Beta cell function markers measured by the HOMA-B score showed statistically significant improvement only in the intervention group. The researchers concluded that the combination of glycemic buffering and beta cell support likely explained the dual effect. At Penn State's Department of Nutritional Sciences, a 10-week randomized trial involving 51 participants with prediabetes and early-stage type 2 diabetes found that subjects consuming 25 grams of ground flax seeds daily showed a 19.7% reduction in fasting insulin levels, accompanied by measurable reductions in systemic inflammation markers, specifically C-reactive protein and interleukin-6, both directly linked to beta cell oxidative damage. Notably, participants with the highest baseline oxidative stress markers experienced the greatest improvement, suggesting that flaxseed's antioxidant effect is most powerful precisely in the people who need it most. A National Institutes of Health meta-analysis examined 23 randomized controlled trials involving a total of 1,717 participants with type 2 diabetes, studying the effect of standardized Nigella sativa thymoquinone supplementation. Across the pooled data, Nigella sativa significantly reduced fasting blood sugar by an average of 18.9 milligrams per deciliter, improved insulin sensitivity by 16.3% on the HOMA-IR score, and reduced glycated hemoglobin by 0.6%. A figure that in context is comparable to the effect of some first-line pharmaceutical interventions at a fraction of the cost and with no side effects. And a 16-week study from the Karolinska Institute in Sweden involving 44 patients with metabolic syndrome who consumed 35 grams of chia seeds daily found that chia supplementation reduced post-meal blood sugar by 21% compared to controls, reduced LDL oxidation markers by 18%, and improved satiety scores, which, over the course of the study, corresponded to an average reduction of 400 calories consumed daily without any dietary instruction. This appetite-regulating effect has direct implications for diabetes management since excessive caloric intake and the resulting visceral fat are major amplifiers of insulin resistance. Here is the exact morning protocol based on the clinical data. First, fenugreek seeds, 10 grams, roughly 1 heaped teaspoon every morning. Soak whole fenugreek seeds overnight in a small glass of room temperature water for at least 8 hours. In the morning, drain and eat the soaked seeds directly or blend them into a smoothie. Soaking breaks down the hard outer shell that would otherwise reduce the bioavailability of trigonelline and galactomannan. Do not dry roast them. Heat degrades trigonelline content by up to 40%. The bitter taste is normal and indicates potency. Second, ground flax seeds, 25 grams, roughly 2.5 tablespoons every morning. Always use ground flax seeds, not whole. Whole flax seeds pass through the digestive system essentially intact. You absorb almost none of the active lignans or ALA. Grind fresh each day or buy pre-ground seeds and store in an airtight container in the refrigerator. Add to oatmeal, smoothies, or yogurt. Rancid flax seeds smell like old paint. Discard them immediately as oxidized flax seeds are counterproductive. Third, black seed, also known as Nigella sativa, 2 to 3 grams, roughly half a teaspoon every morning. The most bioavailable form is cold-pressed black seed oil, half a teaspoon consumed directly or incorporated into warm water. If using whole seeds, lightly toast for 60 seconds in a dry pan to improve digestibility, then crush before eating. Do not cook at high temperature. thymoquinone begins to degrade above 82 degrees Celsius. Regular daily use matters more than dose size. 2 grams for 12 weeks consistently outperforms higher doses taken sporadically. Fourth, chia seeds, 15 grams, roughly 1 tablespoon, with your morning meal. Soak in 3 to 4 tablespoons of water for at least 15 minutes before eating. This forms the gel matrix that slows glucose absorption at breakfast. Eating dry chia seeds means you absorb far less of the fiber benefit. You can prepare a larger quantity the evening before. Add lemon juice to the soaking water. The vitamin C content synergistically improves ALA absorption. Fifth, Ceylon cinnamon, half a teaspoon daily as an optional amplifier. Not cassia cinnamon, only Ceylon cinnamon. Cassia contains high levels of coumarin, which at daily doses is hepatotoxic. Ceylon cinnamon contains negligible coumarin and significant amounts of cinnamaldehyde, which has been shown in multiple trials to improve insulin receptor sensitivity. Incorporate into your morning coffee, oatmeal, or smoothie. Its addition is supported by a 2019 Diabetes Care meta-analysis showing a 0.27% reduction in glycated hemoglobin in supplemented subjects. Sixth, green tea, 1 to 2 cups brewed at 79 degrees Celsius, consumed within 30 minutes of your seed protocol. The EGCG in green tea has its own documented effect on glucose metabolism and AMPK activation, and it complements Nigella sativa's thymoquinone through overlapping but distinct pathways. Brew at 79 degrees. Boiling water destroys up to 60% of catechin content. Do not add cow's milk. Milk proteins bind to catechins and significantly reduce absorption. A squeeze of lemon is acceptable and even increases absorption. Plant milks do not have the same binding problem. Here are 6 clinical details most people miss that make the difference between partial and transformative results. The first is that order matters. Eat your soaked fenugreek seeds and chia gel before or at the start of your largest carbohydrate meal of the day. The glucose buffering effect of galactomannan and chia fiber is most powerful when it is already present in the gut when glucose arrives, not after. The second is to measure your fasting blood sugar at the same time each morning, not after coffee, not after exercise, before both. This gives you a clean baseline to track your protocol's effectiveness over weeks. Most people following this protocol for 8 to 12 weeks begin seeing significant fasting blood sugar changes around weeks 4 to 6, not on day 1. Do not abandon the protocol because you see no results in the first week. Third, pair your ground flax seeds with turmeric. The curcumin in turmeric and the lignans in flax seeds have complementary anti-inflammatory action on the NF-κB pathway specifically involved in beta cell apoptosis. A pinch of black pepper alongside increases curcumin bioavailability by 2,000%. This is one of the most well-documented food synergies in nutritional biochemistry. Fourth, visceral fat is the hidden enemy of this protocol. Even a 5 to 7% reduction in visceral fat, not total body weight, but visceral fat specifically, produces measurable improvements in insulin sensitivity independent of anything else you eat. Waist circumference is a better indicator of visceral fat than the scale. Fifth, consistency outweighs large efforts. The research I cited used moderate, consistent daily doses, not megadoses. Doubling fenugreek intake to 20 grams per day does not double the benefits and in some people causes significant digestive discomfort that leads them to abandon the protocol entirely. 10 grams every morning for 12 consecutive weeks is the evidence-based target. Sixth, whole seeds outperform supplements in this context. Fenugreek capsules, black seed oil capsules, and flaxseed supplements all involve processing steps that reduce the synergistic activity of the fiber compound matrix present in whole seeds. The fibers and bioactive compounds work together. Separating them into an extract loses part of the mechanism. Whole and ground seeds first, supplements as a convenient fallback, not as the primary strategy. Now let us address the mistakes that prevent people from seeing results. The first and most common is using whole instead of ground flax seeds. Whole flax seeds have a hard outer shell that human digestive enzymes cannot break down. Studies confirm that whole flax seeds pass through the gastrointestinal tract with 85% of their compounds unabsorbed. If you are eating whole flax seeds and wondering why nothing is changing, that is probably why. The solution is a cheap coffee grinder or pre-ground seeds kept in the refrigerator. The second mistake is expecting measurable change within the first 2 weeks. Beta cell neogenesis is a biological process that unfolds over months, not days. The studies that showed the most dramatic results, glycated hemoglobin reductions and fasting blood sugar normalization, lasted 10 to 16 weeks. Give this protocol 90 days before evaluating it. Progress will be real and measurable by then. Quitting at week 3 because you do not feel different is the most common reason people miss genuine physiological change. The third mistake is replacing seeds with supplements assuming they are equivalent. A trigonelline capsule is not the same as soaked fenugreek seeds. A thymoquinone extract is not the same as whole black seed. The complete matrix of fiber, polyphenols, alkaloids, and fatty acids in a whole food acts synergistically in a way that an isolated extract does not replicate. The fourth mistake is failing to address the dietary pattern that caused the problem. The seeds in this protocol are powerful biological tools. But if you consume them every morning and then spend the day eating ultra-processed carbohydrates, refined sugars, and industrial vegetable oils, you are working against yourself at a scale the seeds cannot overcome. This protocol is an accelerator for broader dietary change, not a compensation mechanism for an unchanged diet. Type 2 diabetes is not a life sentence written in your DNA. People who genuinely reverse this condition, and the research shows that reversal is possible, not theoretical, are not exceptional people with unusual genetics or unlimited resources. They are people who make small, targeted, biologically intelligent choices consistently and daily. They take their soaked fenugreek seeds seriously. They grind their flax seeds. They do not skip the black seed. And they do it again tomorrow and the day after. Your pancreas has not said its last word. Your beta cells are not all gone. The progenitor cells are there. The regeneration pathways are there. The galactomannan is there in a packet of seeds costing a few euros at the shop on the corner. These biological systems exist in you right now. You do not need to wait for a new drug. You do not need to accept progressive decline as your only option. You can start supporting your own metabolic recovery today, not with heroic effort, but with consistent, informed daily action. To recap everything covered today, the real problem in type 2 diabetes is the loss of beta cell mass, not just high blood sugar. And the pancreas has a documented capacity for beta cell regeneration that is rarely accounted for in conventional treatment. Fenugreek seeds, 10 grams per day soaked overnight, contain trigonelline, which activates PDX1, the genetic switch for beta cell formation, and galactomannan fiber, which physically slows glucose absorption and flattens post-meal blood sugar spikes by up to 25%. Ground flax seeds, 25 grams per day, deliver lignans and ALA that suppress the NF-κB oxidative pathway responsible for beta cell destruction, protecting and preserving the beta cell population you are trying to rebuild. Black seed, 2 to 3 grams per day, activates the master metabolic switch that improves insulin sensitivity by creating alternative glucose uptake pathways in muscle cells, thereby reducing total insulin demand on the pancreas. Chia seeds, 15 grams per day soaked in water, flatten post-meal glucose curves by 21%, reduce LDL oxidation, and regulate appetite in a way that naturally reduces caloric intake and visceral fat accumulation over time. Green tea, 2 cups at 79 degrees Celsius without cow's milk, amplifies EGCG-mediated glucose metabolism and complements the full protocol through AMPK co-activation. Consistency over 10 to 12 weeks is the evidence-based timeline for measurable results. Track fasting blood sugar and waist circumference monthly, not daily. And whole and ground seeds outperform supplements for this application because the fiber compound matrix is mechanistically essential, not accessory. Your health is not predetermined by your genes or your age. The metabolic trajectory you are on right now can be changed. It has been changed in peer-reviewed clinical settings with the exact foods and compounds we discussed today. You have far more influence over that trajectory than you have been led to believe.